Should we get started or? Okay, awesome. All right. So good afternoon, everyone. I know it's almost lunchtime, but I'm going to keep it interesting, hopefully. Um, so far, we've been talking a lot about AI. Uh, every enterprise is trying to incorporate AI in their workload and business logic. But in this talk, we are going to go a level down. AI workload is an application level. We need to first figure out how are we going to build networking and security infrastructure to support AI workloads which are running across multiple public cloud providers. So in this talk, myself, Bhavin, I am a product manager in Google Cloud, and with me is going to be Kapil, who is in Oracle Cloud. We are going to talk about some of the challenges that our enterprise customers face today while deploying their workloads across multiple clouds, and what are the solutions out there that we are building in order to kind of smoothen the process. So let's start with some data. Um, Today, we are at a critical inflection point for AI and ML workloads, and 66% of enterprises have already adopted multi cloud specifically to build AI ML infrastructure. Over 80% of these multi-cloud customers are building multi-cloud networking, and they are trying to figure out what's the best way to build security on top of it, because now your workload is spanning across Google, AWS, Oracle, and multiple cloud providers out there. Cybersecurity is no longer an afterthought. You talk to any CISO, this is like top of the mind. And with AI, it becomes even more important that your data is always secure. Your users, your applications, when they are accessing this data across multiple clouds, they do it in a secure fashion. Now, if you have a single breach, according to the IDC report, at minimum, on an average, enterprises are losing like $4.5 million. So building a strong foundational multi-cloud network and on top of it consistent security is a must. So let's look at today's network, right? These networks were never built for cross-cloud networking and security to access AI workloads. So when enterprise started building networks, what they did is they went to colo, and from colo they wanted to migrate their data into the public cloud. So what they did is first they created a private network from their colo to cloud A, cloud B, cloud C. These are all public cloud providers, and then you have this SaaS internet endpoints as well. So these are services like Snowflake or Datadog. So what happened over here is they started building bunch of bespoke networks all over the place. And as soon as you start building bespoke networks, it becomes operationally very complex to manage it from a cost perspective and also from troubleshooting perspective. The most important thing that you see over here is the security services. This is something that the world saw after pandemic, where most of the workers went remote. So now how do you secure your users who are sitting in any corner of the world and they are trying to access private applications? How do you ensure that there is zero trust policies enforced on top of that? So the solution that became very famous, which we all know, is ZTNA. Providers like Prisma Access, Zscalers, but the deployments were all in colo, and then the customer had to figure out to bring all the traffic to the colo and then send it to all providers. So in summary, we started seeing that enterprises were building bunch of bespoke networks that were super complex to manage, and the overall TCO for the customer went high. So that's where Google Cloud thought of building a solution, what we called as cross-cloud network solution. This is basically to meet our customers halfway. All these customers who are trying to go multi-cloud, in reality, their application stacks are running across multiple clouds, private data centers, and we wanted to meet the customer in their journey. So now the choices are great for all the application guys, but for the networking folks, it becomes even more difficult to figure out a network which is super simple, private connectivity, and has a consistent security on top of it. So as we started talking more to our enterprise customers, what we learned is there are three major patterns, let's put it that way, because of which they are building distributed applications across public cloud providers. So number one is, how do you securely connect to manage SaaS services on Google Cloud from other clouds? So we have bunch of customers who connect to services like BigQuery, Vertex AI, or Spanner databases from other clouds, and our cross-cloud network enables dedicated bandwidth, predictable and low latency connectivity between those clouds. The second use case or pattern which we saw is data migration pattern for customers. So as these customers bring their data to Google Cloud for machine learning, training, running analytics, it is super important that they get a high bandwidth and a private connectivity between their data sources. And the final use case is more of lift and shift. That is, you are moving your workloads from your private data center into Google Cloud. And for that, you need capacity augmentation and reliability. So in today's session, what I'm going to do is I'm going to walk through the whole journey of how a customer can build a multi-cloud network, starting with the underlay network, then going on top of it with a virtual network. Once your networking is in place, what about the security parameters? And then finally ending it with the observability. Because now, since the applications are all over different clouds, how do you give end-to-end observability? So let's start with the base layer. How do you build a robust connectivity? So to enable cross-cloud connectivity between clouds, Google Cloud provides a service called as Cross-Cloud Interconnect. What it offers is that it gives you a high performance end-to-end private connectivity between Google Cloud and any other cloud providers, whether it's AWS, Oracle, or Azure. And we meet in most of the public cloud regions through a co-location. This is end-to-end private connectivity, which is encrypted. And from a customer's perspective, they do not have to engage a third-party vendor or a colo provider to establish this connectivity. So the overall TCO reduces for the customer. Also, this service is backed with the SLA, uptime SLA of 4 nines, all the way from Google Cloud's edge router till the customers or the third party cloud providers edge router. So it's end-to-end SLA that is being provided for the customers. Now, Google has the most extensive interconnect footprint. We currently have 140 plus locations all over the globe where if the customer has presence and they want to connect to other clouds, they can meet us over there. So once we have established this layer, let's call it layer 3 connectivity between the clouds, private connectivity, let's talk about some of the innovations that we are doing in order to build a virtual routing and a virtual network connectivity service oriented architecture in Google Cloud. So there are multiple patterns that I'm going to go over. So for the first pattern is more around how do you simplify your multi-cloud connectivity. So our goal over here is to build a design that scales well with your organization and as it starts growing. So to enable that, you need a high-speed interconnect between the cloud. You need an enterprise-grade BGP routing capability between your VPCs. VPC is nothing but a virtual private cloud, and there are just different names in all other cloud provider. End of the day, think of it as your own network, your own data center in the cloud, where you decide what applications you want to run. It's like your own logical isolated boundaries. But as your apps grow, as your business unit grows, you start sprawling number of VPCs, right? And now this VPCs also need to talk to each other over a private channel. So how do you establish a full mesh VPC connectivity? And then finally, you have your external networks. In this case, either it's a third party cloud provider or your on-prem data center. How do you connect those networks to Google Cloud as well? So that's called dynamic route propagation that can be enabled to bring those on-prem routes into Google Cloud. Between VPCs, they can talk to each other through NCC, which is Network Connectivity Center. It's a virtual hub in the cloud, which allows you full mesh kind of architecture. So that is how you establish your routing within the cloud and bring your external networks also into the cloud. So with NCC or Network Connectivity Center, what we have introduced is VPC as spokes. So these are your VPCs where you are spinning up your applications and workloads which needs to talk to each other. They can either talk in full mesh or we also give you certain parameters for export and import filters, wherein you only want certain subnets to talk to each other. It also now supports dynamic route exchange, which just went public preview a couple of days ago. What it means is that your on-prem routes can dynamically advertise to all the workload VPCs, meaning if the VPC wants to talk to other cloud or on-prem network, you can do that now. And it also allows a higher scale. So now with NCC, you can support up to 250 VPCs, which can talk to each other. And it supports cross org and cross project network connections. Okay. So customers use this routing based architecture today for connectivity to their services. However, sometimes this can lead to challenges, especially when it comes to full route distribution, failover, security injection, and NAT services. So what we did is, there are use cases where we have seen that certain VPCs have overlapping IP ranges, and customer needs to NAT the IP before sending it to the other side. So with NCC, customers can also use inter VPC NAT, meaning they can provide an IP address to which is a non-overlapping IP address that can be exposed to other VPCs, and now you can still have connectivity for overlapping IP addresses. So this is the inter-VPC NAT capability, which allows private networks with same overlapping IP address within the cloud, for example, workload VPC A and workload VPC B, to talk to each other through the NAT subnet provided by the customer. And this capability is also something that can be readily be used by customers today. In terms of inter-VPC NAT, we also have enabled support of reusing the private IP address space between the peered networks. Okay, so this was more around the routing based architectural model. But let's say if you want to further scale your service connectivity such that the customers do not have to worry about connecting each and every workload VPC, what we have introduced is something called as PSC propagation. PSC is a private service connect. It's more of a endpoint talking to a SaaS provider. It's this kind of technology pretty much is available in all cloud providers. In AWS, it's called Private Link. In Azure also, it's called Private Link. Google calls it Private Service Connect. But what we have done over here is we have gone a step ahead, and we have introduced a concept called as PSC propagation with NCC. What this means is that you only create the PSC endpoint once, that you can see in the VPC number 2, and all the workload VPCs on your left side can access, whether it's a Google first party service, whether it's a third party provider like a MongoDB, or whether it's your partner service, can be accessed through that one endpoint itself. So the customers do not have to go in each and every workload VPC to spin up PSC endpoint. Instead, can propagate it through NCC Hub across all your workloads. So this architecture has the following benefits: private connectivity from any workload to any services. It allows the app teams to publish services through private service connect to a services VPC, or what we call a common shared services VPC. It also enables bi-directional connectivity to services where a producer needs to access consumer workloads and access other services. Now, our strategy is simple. Using PSE endpoints, you either can access 1P Google services, 3P services, or your own services that you have published as a SaaS provider. But we understand that many times the use case is other way around, meaning the producer wants to talk to the consumer. So in that case, what we've introduced is something called as PSC interface. What it allows you to do is it enables bi-directional connectivity, meaning the producer, the SaaS producer, if it wants to talk to the consumer, can now have a reverse kind of a direction from customer managed services to service VPC. So essentially, you can either access all the services, consumers can access producers, but we also allow the producer to access consumer in certain use cases. Okay, so that was the part where we talked about NCC, which is a foundation for establishing routing. PSC is more of a consumer service provider model, which both can work together in tandem. And now let's look at how security is going to be implemented in this architecture. So we have a concept called as centralizing internet egress through an internet VPC over there, where there are a bunch of advantages for the customer. Customers can centralize from a security posture. They can implement all the network policies in that internet VPC. They can spin up a SWIP, which is a service which is called Secure Web Proxy. It already supports NAT by default. So what it happens is, if workload VPCs, any of them wants to talk to internet, they all have to go through this internet VPC, wherein you do the inspection, URL filtering. You can also have firewalls over there, and it gets natted and sent out to the internet. The reverse path is going to be exactly the same, because the NAT maintains the stateful connections. So, cloud secure web proxy enables you to achieve zero trust principle. It enables granular access control to only trusted URL websites, and that's where it enables you to control your egress perimeter along with TLS inspection. Now coming to the firewalls, for all of you who have deployed firewalls in the cloud, you must have seen it's very hard, especially when you start deploying a third-party NVAs. NVA is nothing but network virtual appliance in the cloud, because now you have to start making routing changes in your design to insert this firewall. Also, with a centrally deployed firewall, perimeter security alone is not sufficient. So what Google did is, we announced Cloud NGFW, which is a GA product. It is a fully distributed approach, allowing for consistent stateful inspection for east-west traffic as well as north-south traffic. And the rules are enforced all the way granularly at the VM level itself. So this is developed using a novel approach in Google, what we call packet intercept technology, which is right at the host VM level. So any ingress or egress traffic can be intercepted at the VM, then will be sent to the firewall engine to go over its policies, and then the traffic is either allowed or denied based on the firewall policies that you have configured. So the Google Cloud NGFW leverages best of the breed security using Palo Alto threat protection, which is ML powered and URL based. It gives you 20% efficacy rate higher than any other cloud provider. And it also uses Google Intelligence for malicious IP protection. So Cloud NGFW can be applied on each and every workload directly, and can help you to protect against east-west traffic, that is traffic between the VPCs. Internet traffic can also be protected, and that it can also be coupled with the SWIP in the internet VPC. So now you have two kind of stacked layer of security, one at the workload level and one at the centralized internet security level. The next topic is observability. Since we have gone cross-cloud, multi-cloud, how do we provide the end-to-end observability? So in this space, we have made number of improvements over the years after listening to our customers, getting their feedback. So we have something called as VPC flow logs. It consists of 5 tuple, which is source IP, source and destination IP, source and destination protocol, and the port number. It allows you to get 5 tuple granularity for monitoring, analytics, and security analysis. This can be applied at the VM level, the flow logs, and it can also extract from the GK nodes itself. We have also incorporated in our network intelligence center what we call as performance dashboard. This dashboard gives you network latency data and packet loss metrics between Google Cloud and internet, and also between Google Cloud regions and between Google Cloud zones. So customers can granularly troubleshoot if there is any issue at the networking layer using the dashboard. And finally, we also have connectivity test. This gives you the test between two endpoints in Google Cloud. So it's mainly like path tracing. do you have a firewall, or do you have some incorrect routing? It will give you that data. We also introduced Flowlog Analyzer. This tool. There's no additional cost for using Flowlog Analyzer when you query your Flowlog. What it does is it enables the users to group and filter VPC flow logs by source and destination fields. So the application for this is you can figure out which are your top talker applications, and you can use this data to analyze the network traffic patterns, the hotspots, and also figure out the cost. Why is the cost going high? Maybe because these two applications are talking a lot. Is this legit or something else is going on? So this is a very handy tool to figure out analytics of the traffic patterns between your endpoints within the Google Cloud. And finally, to summarize what we talked about, I think the takeaway of this story of cross-cloud network is that we understand that customers are going multi-cloud because of using AI services in multiple clouds, because each cloud has their unique capabilities. So it's important to first set up a simple and scalable network connection, which is private. Secondly, provide a consistent security model, not only for app to app connectivity, which is done through firewalls, but also between user to app, which is done using SASE connections, managed SASE connections. And lastly, use first party cloud provider security services as much as possible, because they are natively integrated with all the endpoints in the cloud provider and are completely distributed. Now, just to further go ahead, Kapil will talk about the multi-cloud partnership between Google and Oracle Cloud, which was announced recently.
Hey folks, so I'm gonna take 5 minutes of your time to talk about the multi-cloud partnership that was recently announced between Google and Oracle. So Oracle, as you know, is mostly known for its database services. That's where most of our customer base relies. And behind the scenes, Oracle has been one of the first major cloud companies to partner with Azure on the multi-cloud solution. After Azure, Google being the next AI leader, we thought of partnering with Google Cloud using the multi-cloud solution that Bhavin was just presenting. This is mostly because a lot of our customers of Oracle Cloud want to access the AI services or their local services that they're running in Google Cloud, but they are finding difficulty in managing both the clouds. So a multi-cloud solution was a logical next step. Since we had already done it with Azure, we started working on Google Cloud. And we announced this formal partnership earlier this month. Some of the key offerings that Oracle Cloud and Google Cloud using multi-cloud solution, the key offerings that we are announcing were, one is Oracle databases as Google Cloud, and then Google Cloud cross-cloud interconnect. Using Oracle databases at Google Cloud, you can seamlessly run Oracle databases, leveraging best of both worlds. You can use Oracle databases performance and Google's innovation that they are known for. Using cross-cloud interconnect, you can effortlessly interconnect both the clouds together. And we'll talk about that in the next slide. But the best part is you can do that with zero cross-cloud transfer charges. As you know, most of the time when you are sending any data to a cloud, there are no charges. But when you are extracting data out, any cloud provider will charge you for egress traffic. But with our innovative solution, you don't have to pay any cross-cloud transfer charges either for ingress or egress. Some of the key benefits that you can see is flexibility of choice, simplified migrations, enhanced performance, unified experience, access to Google Cloud's AI, and cost of optimization. It's very easy to connect both the clouds. There are some prerequisites where you have to have accounts on both the clouds, but you can see on the left-hand side is Oracle's solution called as Fast Connect and Google solution called as Interconnect. These are very similar to Amazon solution, which is Direct Connect. These are peer-to-peer connections, which are fast and secure. You can either connect via 10G connections or 100G connections. You can, if you need more bandwidth, you can always lag them. But this creates a seamless connection between both the clouds, which gives you an ultra low latency connectivity where you can run both your services in Google Cloud as well as in Oracle Cloud. You can access Oracle Cloud's databases using your Google Cloud platform as well as Google Cloud services using your Oracle Cloud platform. And we have some detailed steps on how to access or how to access the service of multi-cloud for both OCI as well as Google Cloud. But yeah, that was it from us. Yeah. Thank you.
Hello. Hey, first off, great slides.
Sorry?
I said great slides, very beautiful stuff.
Thank you.
But I'm curious, just, well, for one, just on the last thing you guys mentioned, many customers adopted this Google partnership yet, or when is that officially rolled out?
Yeah, so I think the joint release, press release just went out June 12th, just like recently. So the solution is going to get GA soon, and there are customers who will start onboarding. But yeah, it just went out. So yeah.
Okay, cool. And then I guess I'm just wondering, for you, Bob, what are the most common cloud security issues like your customers?
Yeah, I think the biggest one is how do you provide a consistent security model across the two clouds, right? Every cloud provider has their engine of security. And how do you secure app to app communication, right? So you have security level at workloads, you have security at perimeter, and you need to make sure how you do it consistently. So with the cross cloud network, what we are saying is that you can implement security or use Google's backbone for routing as well as security, and just access multiple applications across multiple providers, right? So keep this as a center space for applying security in networking and using cross cloud interconnect connect multiple clouds. So that's more on the application side of things. But the second one which we talked about is the remote workforce, and that is very challenging, right? Because everyone is remote, you are sitting in any corner and you're still accessing your internal website, right? Your internal apps. How do you make sure that you understand the user ID, device ID, and the context, and still make sure security is applied consistently? So that's where we excuse me, we've been working with multiple SASE vendors out there to provide a managed solution wherein you bring in all the traffic to Google Cloud. We apply the SASE vendor policies, and then the final destination app can either be in Google Cloud, Oracle Cloud, or Azure Cloud. The security is applied once, and then you can go to a final destination. So it's mainly around how do you stitch the network and security together in a multi-cloud environment. And cross-cloud network solution is all about being that centerpiece of doing security and networking. And even if your application is not in Google Cloud, that's fine, but you can do it at one place. I think that's the initiative, basically.
Thanks.
Yeah. Hmm. Yeah. So I didn't get the last part of your question. If you can.
Oracle database in the rack, either in model and in Google Cloud application directly in Google.
Okay, I think that's a great question. So the bare metal service, the BMS, right? So that solution still exists. The customer wants to use it, you can use it. BMS is more of like hosting Oracle in Google Cloud. BMS is more of a region extension to existing Google Cloud. What this offering it does is it's going to allow customers to spin up Oracle DB directly on the Google Cloud region itself, but the management will be done by Oracle, right? The Oracle Cloud, and that's done through the cross cloud interconnect. As far as the egress cost is concerned, so far in the joint press release, what Google has said is if there is any egress from my cloud, meaning Google Cloud to Oracle Cloud, we will not charge you any, like it's zero cost. Otherwise, there is always 2 cents per GB charge, right? Ingress has always been free in any cloud providers, just the egress. So yes, to answer your question, if you make an egress query out, if when this solution goes GA, Google will not charge you for the interconnect egress cost.
If that means the Oracle database is running on.
Yes, it is running on Google Cloud. With this offering, it's like literally running on Google Cloud, but until now it was on BMS, right? This is more of like a first. Think of it like Oracle running on Google Cloud, but almost like you're running a rack, right? But it's completely managed because it's a joint partnership. So Oracle is going to monitor, maintain as well, and give that capabilities to Google Cloud to run it natively on the stack. Otherwise, BMS is more of like DIY for the customer, right? This is like completely managed Oracle on Google Cloud itself. Yeah.
So that will involve the hardware charge.
Interconnect to other cloud? Yeah. So with Google Clouds, so Google Cloud has 2 flavors of interconnect. The first flavor is like a regular interconnect, wherein you as a customer have to figure out a presence in the colo, right, and think about a hardware. The second flavor, which we released last year, I believe, was called cross cloud interconnect. In that, as a customer, if you want to connect 2 clouds, you don't need any hardware, you don't need to go through any colo provider. The only thing you need is you go to, let's say for example, AWS or Oracle, ask for their version of interconnect. So for example, AWS is direct connect, Oracle is fast connect. Get their letter of authorization, give it to Google Cloud, order a CCI, and then what happens is from a physical layer, Google puts a fiber in their router in the colo and does the fiber connect all the way up to AWS or Oracle's Meet Me room. There is no hardware in between. So basically, you are getting end-to-end line rate, end-to-end private connectivity. So that's the feature basically. So there's no, and that was I think one of the main asks by customer, that why do I need a virtual router? Why do I need a hardware in the cloud, right? And that offering basically eliminates that bottleneck.
The last one is that since you also have agreement with Azure, and you Oracle you have a unique solution. And for Azure, you see a charge, let's say application runs on get the egress, the data comes flow out from Oracle and into GCP for you to use. So in that egress, you see a risk.
So if I understand your scenario correctly, the data is coming from Azure to Oracle to Google?
From Azure to directly to Google.
Over the cross-cloud interconnect?
Over the cross-cloud.
Yeah, so in that case, for Google Cloud, it's ingress. So Google Cloud doesn't charge, but Azure might have an egress charge. So that is based solely on provider. But with the unique partnership of Oracle and Google, that's a different partnership, right? I think what Google is saying is we won't charge any egress cost, and it potentially may happen that depending on what the final GA product is, Oracle also might say the same thing. But if it's coming from Azure, we don't, Google and Azure or Google and AWS does not have any such partnership. So the other provider is always going to charge you egress. Google is not going to charge you ingress fees.
Yes, Google, the Oracle, the joint partnership is different.
Yeah.
The software is the Oracle workload is running on code.
Yeah.
So certainly there's no control.
Mhm.
Right? That's the kind of so-called innovation.
Correct. Yes. Yeah. Correct.
That's all.
Thank you.
So my understanding is this kind of multi-cloud solution is similar to what currently Google is doing with Fabric or Snowflake. Is that really similar roadmap we are following right now, or there's a bigger difference?
So Google is doing with Snowflake, you said?
Yes, and Daybreak. Daybreak is also has the coordination. Yeah, go ahead.
Yeah, I see. So the way Snowflake and Databricks solution is offered in Google Cloud is like these are typical SaaS providers, right? So the way they can be consumed by the customers, either of Google Cloud itself or coming from on-prem or other cloud, is using Private Service Connect. So it's a consumer and a SaaS provider multi-tenant model, wherein uh, customers can access the PSC endpoint itself, and each PSC endpoint has a unique identifier which is sent to Snowflake or the third-party SaaS provider, and they can identify or get the multi-tenant context and respond back with the appropriate response without the traffic mixing up between the customers. So the model over there that we are asking customers to use, or rather we have offered, is use a PSC endpoint or private service connect endpoint, and Snowflake exposes their service which can be consumed using the private service connect endpoint. So whether you are in Google Cloud within a VPC, or you are in other cloud or data center, you can access that PSC endpoint, which is a private routable IP, and through that private routable IP you access the SaaS provider solution.
My question is more on the user side. If I'm working operating on a break, like supported by Google, or I'm operating on Snowflake or Daybreak, I didn't really see Google Cloud at all because I log in Snowflake, I only interact with Snowflake. I work with Daybreak, I only interact with Daybreak. The backend action is between Daybreak and Google or Snowflake. That is similar setup as we're talking about right now. So I operate it, I only, as a user, I only see Oracle, but the backend is running, operating on Google Cloud. Is that a similar setup?
Yeah, so that actually depends on the implementation of each provider. So for example, bunch of this third party provider first started offering their services in AWS because they were the first in the market, but now we see these providers offering in all the clouds, right? So if your third party is hosted in Google Cloud, like for example Snowflake is hosted in Google Cloud, it really depends on how Snowflake wants their end users to access it. So to give you an example, right? There's a big retail company which is a competitor of, let's say, Amazon, and they want to use Snowflake. They wouldn't access Snowflake in AWS. They will go to Snowflake and say, I want to only access it if it is hosted in Google Cloud. So the routing under the hood is done by Snowflake to send it to the appropriate cloud. Does that make sense?
Yes, yes.
Okay.